When I was 10 years old, I used to live in Shepherd's Bush, not that far from here. And every Saturday afternoon, I used to go to Shepherd's Bush Market, where there was a very strange man every Saturday afternoon selling medicine. He was selling medicine in little bottles like this, and he told everyone that these tablets could cure you of any problem which you might have, whether you had a headache, toothache, migraine, muscle pain, rheumatism, neuralgia, even nostalgia. This, he said, would cure your problem. And the reason why this would cure your problem is, unlike many other medicines, this does not contain any acid. And he had some examples of medicines which contain acids, and he told them, when medicines contain acids, acids burn, and therefore they're bad for you. He had some examples of medicines which contain acids. He had, for instance, a tin of Burdol Seidlitz powders. Now, this is used to treat constipation. He read the label on the side. It contains tartaric acid. Acids burn, he would scream. And then he had a tin of Andrew's liver salts. Now, Andrew's liver salts are used to treat indigestion. He read the label on the side. These contain citric acid. Acids burn, he screamed even louder. And then he had a small bottle of aspirins. Now, aspirins are used to treat headaches, migraines, and so forth. He read the label on the side. These contain acetyl salicylic acid. Rather than telling you what this could do in your stomachs, he said, I am going to show you. So people were intrigued. What was it that he was going to show them about this terrible medicine which contains an acid and which can burn you? He had some dark purple crystals on a tin lid every Saturday. Then he said, he put the aspirins on the crystals, and then he said, when you are suffering from a headache or a toothache, it is entirely possible that you might have a sore throat as well, in which case you might like to take some cough syrup. And he had a bottle of Sanatogen baby cough syrup, and he put some of this cough syrup on there like that. And then he said, when you have taken these medicines, you might not like their taste, so you might like to drink some water. So he sprinkled some water. And then he said, watch carefully, because in the next few minutes or seconds, you're going to see what this horrendous medicine containing an acid can do in your stomach. And then suddenly the whole thing started steaming and smoking and burst into flame. And at this stage, people were absolutely terrified. And they started fumbling and bumbling around in their pockets. They said, I don't want to have that happening in my stomach. And as they fumbled and bumbled around, this is what they found: 2 shillings and sixpence, half a crown. This is what people were, every Saturday afternoon, everyone was buying the magic medicine man's magic medicine, but not me. You see, when I was 10 years old, I was very lucky because I was never ill. Secondly, I had no problems, no money, so I had no problems. But what I wanted to say is that ever since I had been a tiny baby, I had developed a serious psychological malfunction. I had developed a secret and passionate obsession with fire. Now, my parents had bought me a chemistry set when I was 8 years old, and I used to mix all the ingredients together in the chemistry set in an attempt to make fire. All I succeeded in making was fizz pops and smells, nothing like the magic medicine man at Shepherd's Bush Market. So I decided I would try to repeat his experiment. Now, I knew where I could get the aspirins from. They came from Boots the Chemist in Uxbridge Road. I knew where I could get the Sanatogen baby cough syrup from. That, too, came from Boots the Chemist in Uxbridge Road. I knew where I could get the water from. That came from the tap. But I didn't know what those crystals were. So I decided to find out. I went along to Shepherd's Bush Library, and there I borrowed a book called Chemistry Magic. And in that book, I read about all the compositions of pyrotechnic mixtures, what sort of substances are used for making fireworks, to see whether in those substances, among those substances, there might be something which would fit the description of those purple crystals. And yes, there was something. It was called potassium permanganate. So together with the other ingredients, I procured some potassium permanganate. I set up the experiment in my mother's kitchen at 44 Standake Road, Shepherd's Bush, London, W12. And lo and behold, within half a minute, the whole thing burst into flames and filled the entire kitchen with smoke. That was the greatest moment of my life, for that was the first truly successful chemistry experiment. I had succeeded in making fire using medicine and water. Now, at this stage, you probably think I was developing into a pyromaniac. Nothing could be further from the truth. In fact, I was developing a secret and deep and passionate interest in chemistry. And I have the evidence to show you of my interest in chemistry, because if you look at wrote my diary from 10th of March 1963. I said here, I went to Rickwood's house and we made some hydrogen, oxygen, coal gas, sulfur dioxide, and carbon dioxide. Dear ladies and gentlemen, that's half a year's work in one day. That's how passionate I was about chemistry. And my passions continue to develop further, and they did start getting a little bit suspicious. You see, because I then, 12 days later, I purchased some red phosphorus. Now, that's the beginning, that's an incendiary, so I was beginning to step into the wrong direction slightly. The pyromaniac was beginning to manifest itself. Now, I was very fortunate because I got into a very good school called Latymer Upper School, and I was there from, as you see, and I had the misfortune though, because at Latymer Upper School, I had the strictest teacher in the school, the Reverend Horace Bamfield, and he taught me through chemistry throughout my entire time at Latymer Upper School. So this proved to me to be a certain hindrance. We were all terrified of the Reverend Bamfield. Please have a look at one of my exercise books just to see how strict he was. This, you see, is an experiment which I had written up. He put a straight red line through the left-hand side, and then he said, rewrite entirely, obey instructions. And if you look at the diagram, it says, poorly drawn. I hadn't put the labels. I hadn't put the labels correctly half an inch away from the diagram, and I had not used a label, a straight, or should I say, a straight line or a ruler for the line that illustrated them. So there were problems with Mr. Bamfield. It was a very difficult time for me, and gradually, though, my interest in chemistry started evolving. And if you look at my report, this is my report. Once again, from Form 4A1, way back in some stage. And if you look at my chemistry report, it says something like quite good, and then it says good work, and then I couldn't decipher what the dickens it said. You see, it was written in such, so once I had deciphered it, I couldn't understand it, because it said must curb his loquacity. So I had to look up what loquacity meant, and in fact it meant that I talked too much. But all of the other reports also said this. So that was a time when, as I said, I was having quite a tricky time with my overexcitement and overexuberism. And I decided, I was still writing my diary at this stage, and I decided, since my diary was beginning to become filled more and more with names, or what I'd call evidence which might work against me, because I was describing processes which I shouldn't. I started writing my diary in Polish because I thought no one could understand it. But you know what? I was so stupid that the only words which would incriminate me were actually written in English because I didn't know the translation. And if you look at that, you'll see acetylene. Well, what a dumb thing to write if you don't want anyone to understand it. And then there's two other words which you can recognize: silver acetylide, which is a high explosive. But the point of that, of course, was that I was actually highly enthused by my chemistry lessons. And what's interesting, very interesting comment actually is, you know, in diaries you only write the most important things of the day. So that was important. But there was a second most important thing which is written in the last three words, which means in the evening I did my homework. Now the reason why I wrote that is because I virtually never did any homework, so it was a significant event for me. And therefore, I think at this stage, and since acetylene is on the topic, I should show you how to make some acetylene and explain a little bit about the chemistry. So acetylene is made by allowing water to drop onto calcium carbide. Now I'm going to do this extremely carefully because the reaction is very, very vigorous indeed. There are a few lumps of calcium carbide, and as I turn my tap, you'll notice bubbling very rapidly, plenty of bubbles. And those bubbles are bubbles of acetylene, but they're mixed with air. And I'm going to just allow this to go for a little while. This takes a little time, this experiment, so we must proceed carefully. And by now, I would like to think that the acetylene is almost, I have to do it very carefully. There we are. And now we put the gas jar on. We put the gas jar on, and we allow the acetylene slowly to bubble. Now, I'm going to set this acetylene on fire. Chemical formula C2H2. It's highly unsaturated with a triple carbon-carbon bond, and it burns with an intensely smoky flame, as you'll very shortly see. But the interesting thing about acetylene, which is what caught my eye, is the fact that it forms unbelievably explosive mixtures with air, but especially with oxygen. So I'm just going to collect a little bit more acetylene, and I said I have to be very careful here. There it is, and I'm going to, as soon as the jar is ready, I shall put the lid on there, and that's one jar here. Now, I'm going to ask you to watch carefully, because the second jar, I'm only going to fill it about 1/10. About 1/10. There we are. That's enough. And now watch what happens. See, that's acetylene in there, and I'm going to now take the lid off. And you see, I've allowed air in. The acetylene, the water has been replaced by air. So here we have a mixture of acetylene and air, and here we have pure acetylene. Please watch carefully how they burn. They do burn quite differently. And the fact is, as I said, by the way, that reaction will carry on bubbling, and we're going to leave it there just to carry on gently. So please watch carefully as we ignite this, and how the acetylene burns with a very, very smoky flame. This is an incomplete combustion, you see, like that. However, when it's mixed with air, it forms an explosive mixture, so it'll burn much more rapidly, hopefully with less smoke. And there you see, there's no smoke at all, and that was very angelic. You say, well, that's no explosion, that's nothing to talk about. But let me tell you a little story. When I was a young teacher, I had just begun at Highgate School in the early 80s, in fact, and we were doing these experiments. This was all on the syllabus. And one of the pupils said, sir, could we try filling a dustbin liner with oxygen and acetylene and see what that does? I said, look, that sounds like a great idea, because it's a bit mundane doing this thing. So it's very easy actually to fill. I'm not going to tell you how to do it, but to make acetylene and oxygen simultaneously is remarkably simply. And so we filled a reasonably sized dustbin liner with acetylene and oxygen, and we detonated it on the school field about 50 yards from one of the boarding houses. Now this made such an enormous bang that all the windows in the boarding house rattled. The housemaster came chasing to see what had happened. All he found was a crater. We had long disappeared into the darkness. Now, I wanted just to show you an example. I have Andres with me here today, who's just going to demonstrate for you an acetylene cannon. Now, what he's got in here, this is, by the way, a commercially available, it's a sort of a toy, and it's America it comes from? Yeah, so this comes from here. In this, basically, it shows you acetylene exploding. I'm not going to show you an explosion as such, but this is a toy, really. And, of course, acetylene was very widely used in bicycle lights and for lighting, because when it burns, without having been premixed with air or oxygen, it does give off a very, very luminous flame, which I'm sure you saw here for a very, very brief period of time. Now, Andy's going to put a tiny piece of calcium carbide in there. He will then add to it a few drops of water, and there is a little percussion cap which he hits. And there it is, you see. So just a little demonstration. Thank you very much, Andres. Much appreciated. Now, going back to my days at Latymer Upper, unfortunately, you see, I kept on getting sidetracked, and my interest in explosive chemistry were developing more than my interest in the A-level syllabus. And this is reflected by my next piece of documentary evidence, which is a test result. And you see there, and the Reverend Bamfield was indeed extremely strict. And what he wrote here, I get 4 out of 25, and he wrote at the end of the test, you display the fact that you've not yet started to work this term. I had to get up in front of the audience, he dressed me down in front of the audience, and I started crying. Now, I did take criticism very seriously, of course, because I really did want to do well, but I just couldn't focus on doing the things that were necessary. But I did decide I would take my chemical studies much more seriously. So I started reading more widely. But unfortunately, my reading went in the wrong direction. And I was reminded of this by one of my friends for my chemistry set. His name was Les Smith. Les Smith wrote to me an email about 12 years ago. We haven't been in touch for many years. And Les said, it would be great to meet up again, Andrew, because, we haven't seen. And I said, Les, it would be fantastic. And he said, do you know what? The single memory, the greatest memory, the most vivid memory that I have of you at Latymer Upper, my whole career at Latymer, was this enormous explosion which you made during a chemistry lesson. And I thought to myself, yes, that is it. I'd forgotten about this. So let me tell you about this explosion. Because in the context of my reading, I had discovered there's two things, in the context of one of the books. It said you must never, ever heat together a mixture of phosphorus or any phosphorus compound with potassium chlorate. So we were doing a chemistry synthesis, an organic synthesis, and the Reverend Bamfield had left us in the chemistry laboratory by ourselves, and it was surrounded by wonderful chemicals on all the cupboards. So I found some potassium hypophosphite and potassium chlorate. Now I mixed them together and I put them a Bunsen burner under this on a tripod, and I expected basically to see a large flame, you see. But after 5 minutes, absolutely nothing had happened. So I became rather concerned, and I thought that, but then Almighty suddenly, out of from nowhere at all, the most almighty bang you've ever heard. Everyone's ears were ringing, and everyone looked at me. Well, I just didn't know why. The people were looking at me. The Reverend Horace Bamfield came running to the door, put his arms like that, and he just looked straight at me. Now, at this stage, there were two words which came to his mind: expulsion or forgiveness. Fortunately, he was a minister of the church, and he chose forgiveness. So my career at Latymer Upper continued. But I thought it would be appropriate at this moment to actually show you this experiment. And this is, by the way, this is what happened. You see, that's the gauze before I put the chlorate mixture, hypophosphite, and that's what happened afterwards. This hole was blown straight through with an almighty bang. So I'm now going to demonstrate these experiments to you. Now, I'm going to show you, first of all, obviously a slightly smaller version of this, and I'm going to demonstrate. First of all, I'll say what I'm going to do, then I'm going to do it. There is, in here, I'm going to put 10 milligrams of potassium chlorate, a tiny, tiny amount. Then on top of that, I'm going to pour a few drops of a solution of white phosphorus and carbon disulfide. Carbon disulfide is an excellent solvent, and it will evaporate in a very short space of time. It has a very strong smell of cabbages, by the way. And when it evaporates, it will have a mixture of white phosphorus and potassium chlorate, which is absolutely lethal when you strike it with a hammer. It is what we call a percussion. And I'm now going to, as I said, very gently put this on. Now, while we're waiting for this to evaporate, I'm just going to put on just a tiny bit more. There we go. And I do have to warn you, I do get carried away, but I think in a place like this, we should make use of our supreme facility. Now, so there it is. I now have to put on about 10 milligrams. It might be 12, but I'm pretty certain I have to do this very carefully, by the way. So there it is. I'm now going to, this is a tiny amount of a solution of, as I said, of white phosphorus and carbon disulfide, and I have to put on literally just 5 drops. So sorry, I put 7 on. But now that's going to take approximately 2 minutes to evaporate. Now, in the meantime, so this is going to be the detonation which occurred which blew this up, but this is a much smaller version. But I wanted to show you, Andres now is going to show you the concept of a period of induction before a chemical reaction occurs. So that means that you're heating something, you're trying to get it to happen, but actually nothing happens. But then suddenly there's an almighty reaction. And that almighty reaction, you see, is what you're going to have here. Now, what he's got on there are 2 spirit burners, both of which which have got 2 spirit burners, and there's going to be a flame coming from them, which is going to warm up some yellow powder. Now, yellow powder is most unusual. By the way, I have to warn you at this stage, there could be very loud bangs. These are seriously loud, and if you're afraid of sudden explosions, you should put your hands over your ears like this. And what's going to happen, that yellow powder is very unusual. It's a mixture of potassium nitrate, which is used in gunpowder, potassium carbonate, and sulfur. So it's called yellow powder because that's the color of sulfur. Now, while we're waiting for these experiments to take place, and I do warn you these are very loud bangs, and there may be other things, I'm going to show you a slightly broader approach, and I'm going to show you some color explosions. Not every explosion has to be fire, etc. We can have visual explosions, which are very beautiful to look at. So watch carefully as I do these. At the moment, these are not going to go off. By the way, Andres has put very large portions. I only use half that amount. And I did say to him for a special audience, but I think, Andres, this is seriously, I'm probably going to finish these because I'm so tired. But just observe color explosions. Lead iodide, mercuric iodide, lead sulfide, lead sulfate, copper, iron 2 ferrocyanide, copper arsenite, forgotten that one, mercury 2 carbonate, and here we have cadmium sulfide. What a magnificent selection of colors, all done explosively. Actually, I don't think they're going to go that rapidly yet because he's put so much on it'll take longer. But in the meantime, let us just carry on. Let's just carry on and see how this goes on. Those will go, we'll just carry on here. As I said, it is a very loud bang, so I do warn you. Let's see if this one works. This one too ought to make a loud bang. And there it is. 1, 2, 3. You see, third time lucky. So that's a bit of excess white phosphorus burning. So we'll put that out. So these, you see, this is a little bit of demonstration. As I say, that is going to go very, very loud indeed. And I'm going to carry on, though. So what had happened? Once I had survived at Latymer Upper, my classmate said to me, Szydlo, okay, you've impressed us with your explosion. And there you see, there's the first one. And I had just then, at that stage, you see, I had just started taking. So there we are. Thank you, Andres. Very successful indeed. Brilliant. And they said to me, my pupils, my classmates said, I had just started taking up a new hobby of photography, you see, and it was very rare in those days because I was interested. I had learned to develop my own films in the school darkroom, and I used to occasionally bring a camera. And they said, Szydlo, we dare you to take a photograph of Bamfield while he's teaching. I said, certainly, no problem. So here's the result. And there is a picture of the Reverend Horace Bamfield taken by Andrew Szydlo when he was 17. And notice a beautiful periodic table there. It's only got 103 elements on that. But you could just imagine the stern look on his face. Now, to celebrate that and to take my luck further, I said, in that case, let's do something else which is highly illegal. And they doubled down. Actually, I didn't. To celebrate, I went to the highest place at Latymer Upper School, which is on the roof of the geography building, and I got a friend of mine to take a photograph in a strictly banned location at Latymer Upper School. And those of you who went there, that's River Court Church, of course, and it's still standing, and I think the skyline would have changed dramatically. So that's how I looked when I was 16. Now, from Latymer Upper School, I went to Imperial College. At Imperial College, I studied chemical engineering, but then I went on to do a master's degree in industrial safety. Now, what do you think were the subjects that we were studying in industrial safety? Well, I've got some notes. I took notes, and there we are on the 14th of January, notes on gas explosions. The next one we look at, dust and mist explosions. Notice this was significant. Haswell, Colliery, Faraday, of course. Here. This was a huge topic. And then the last one, it says explosions yet again. And you see, and this time, notice, by the way, acetylene. Acetylene is a huge topic in the history of chemistry and indeed in the history of industrial safety on account of its explosive properties. Having succeeded in doing the lecture notes, I did the exam paper. What do you think was the first question about? Explosions. So you can see it's no coincidence that I feel reasonably confident when talking about explosions. I have a degree in this subject. Now, from Imperial College, I was very fortunate. I got a job at Cardinal Manning Secondary Modern School in North Kensington. There was a desperate shortage of chemistry teachers, so they took me. And it was there, you see, that I experienced, with wonderful pupils and teachers, it was there that I experienced a class evacuation. Now, a class evacuation is basically when you conduct an experiment which was so huge that everyone has to leave the class. Now, allow me to tell you how this happened. The circumstances were that I was teaching. Oh, by the way, this is the camera I took the picture of the Reverend Horace Bamfield with. It still works very well today. As I was saying, I was teaching a subject of elements, compounds, and mixtures. And the idea is that you can combine two elements. The compound will have completely different properties. So the standard experiment, which everyone did, was iron and sulfur reacting to make iron sulfide. That in itself is a perfectly decent reaction. It's a strongly exothermic process. It glows, etc. But I thought to myself, hang on, Szydlo, there is a more reactive element than iron, which reacts with sulfur, and that is zinc. Why don't we try a mixture of zinc and sulfur? And what happened is I placed a mixture of zinc and sulfur on the front bench, you see, probably a good tablespoon's worth of each, approximately measured out. And I expected it to glow. I hadn't done this experiment before, but there was this almighty flame, huge amounts of smoke, and it filled the entire room was filled, and we had to evacuate the class. So I thought at this point it would be appropriate to show you this experiment. And the zinc and sulfur reaction. Now, those of you who are studying chemistry, I hope you can recognize what's going on. And obviously, I'm doing it in a much smaller scale. It would be most embarrassing to have to evacuate the Royal Institution for a second time. I've succeeded once already. So here we have. Now, this is a mixture which contains. This is a mixture of 2 grams of sulfur with 12 grams of zinc. Now, for all the chemists among you, you will know that these are non-stoichiometric proportions. The ratio of zinc to sulfur is far higher than is demonstrated by the equation. Zn 65 and sulfur is 32. So it should be roughly 4 grams of zinc to 2 grams of sulfur. But I've got 12 grams of zinc. And the reason is, I don't know why. I've written a second equation there. And what's interesting about this is that the zinc sulfide, which is formed in a very strongly exothermic reaction, actually itself burns in air. And that's my own assessment of the situation. No one's ever written anything about it, but I've done the experiment, so I know about it. So that now is there. I'm using, by the way, the same mixture that the trickster, because the man at Shepherd's Bush Market, of course, was a total scammer, and he was ripping people off by terrifying them into buying them things that they don't need. Thank you so much. Now, allow me just to explain what I've done. So there's the mixture of zinc and sulfur. It's 12 grams of zinc and 2 grams of sulfur. I've topped that off with a bit of potassium permanganate and glycerine. All the stories the chap said was a complete pack of lies. It's basically not cough syrup, but it's just simply glycerine, propane, 1, 2, 3 trial. I'm adding a few drops here now. And now I have to squirt. Water, by the way, is just a catalyst. And at this stage, there we go. Andres, let's put that on. And hopefully, the zinc-sulfur fusion will take place in a few minutes to our satisfaction. And as I say, it might help to dim the lights if it's possible, but it's too late now. I think, well, let's see if we can dim the lights. We've still got a couple of seconds left. So that's brilliant. Thank you. That's absolutely phenomenal. Now, let's hope it catches fire. Yes? Are we? Yes, and there it is. So there it is. Thank you very much. So that's the zinc sulfide fusion. Now, you can imagine, thank you very much, Andres. Now, you can imagine doing that. You can imagine doing that in a class on a large scale. It wasn't surprising it was evacuated. Now, what I have to tell you at this stage is I had a very, very happy 2 years at Cardinal Manning School, but then I ended up teaching chemistry at Highgate School in 1975. Now, this was for me the dawn of a new era, because what I found out is not only was I keen on unusual and exciting experiments, but every one of my colleagues in the department was. And here you see them. On the left, Humphrey Barnacle, Mike Morell, head of department, Peter Knowles, and Andrew Szydlo on the right. Now, it turned out that all 4 of those were phenomenal enthusiasts of chemistry, and they supported everything, and we had a chemistry society which was founded in 1972. And what they did, when I started going to the chemistry society meetings, the pupils started noting that I could do unusual experiments, and I could perhaps achieve a result which even impressed my colleagues. I, by the way, was the baby in the department. I was the youngest person in the department, and we stayed together, all 4 of us, for 21 years. We taught together, we became friends, and every Friday after school it was chemistry club, followed by a visit to the pub, of course, and to describe the experiments. Now, what then happened was the pupils noted that I was quite good at doing these experiments, so did my colleagues. Say, why don't we start doing lectures where you can invite other pupils from the school, and we could show explosive experiments in the Highgate School chemistry department. So you see, here is a ticket, Explo 82, and we started doing these. We started doing these experiments on a regular basis, you see. And there you see 9th of July and so forth, and the tickets. And notice, by the way, it starts off on room 26, but then it proceeds to junior field. Now, that gives you something of an inkling of what was to come. So there it was, and I've just got some slides here to show you photographs. So that's from one of the explos. I'm on the right. Mike Morell, head of department. They were all just as keen as I was on these experiments, as Stanley and another colleague in the background. Now, that's a mixture of ammonium nitrate and zinc powder, which is ignited with a few drops of water. On the next demonstration, this is a small-scale zinc sulfide. Obviously, zinc sulfide is always good value. And the next one we have is sodium exploding in water. And, of course, I used to do this on, I used to have 4 safety screens, and I used to chuck in a large lump of sodium into half a beaker of water. There was an almighty explosion, red sparks everywhere, orange spark, and all the screens were flattened. But that's just to give you an example of the sort of thing we got up to. Now, we used to invite the local press. They were very interested to see on this particular occasion, you see, this was celebrating the launch of a book by one of my first pupils at Highgate School, Hugh Aldersey Williams, who is here this evening, and it was he, incidentally, who founded the Chemistry Society of Highgate School. And Hugh is there on the right-hand side. We were celebrating the publication of his first book, The Most Beautiful Molecule. It was about Buckminster fullerene, and which he dedicated to all the members of the Chemistry Society. Now, what's particularly, not the Chemistry Society, but the chemistry staff of Highgate School. And I'm standing there in the middle. Now, what's interesting is the title of this. You see, they called it the Live Chemist Society. And the reason why they did this was to distinguish it from the Dead Chemist Society. You see, not every person actually made it. But we were fortunate for all the experiments that we were doing. We were there to tell the tale and to move further. But you mustn't get the impression that Highgate School was just about doing explosions and being silly, etc. There was some very very significant, serious teaching. And we were teaching in that particular time. We had to teach, we were teaching group 4 of the periodic table, which is the A-level chemistry syllabus. And this was particularly interesting because the elements go from non-metals at the top to metals at the bottom. Specifically, it was carbon, silicon, germanium as semi-metal, and then we had tin and lead. And those were very interesting chemicals, elements, because they demonstrated the properties of metals to non-metals going from bottom to top of the group. And that had to do with electron configurations, with types of bonding, and with the properties of the compounds, which you compared. So one of the things was to compare the properties of the chlorides. And there you could have chlorides of with the element in a divalent state, like tin 2 chloride, SnCl2, or you could have chlorides in the tetravalent state, so for instance, tin 4 chloride, SnCl4. However, a particularly important element in this respect was the tetrachloride of silicon. Silicon tetrachloride was on the syllabus, and everyone had to know that silicon tetrachloride is very, very easily hydrolyzed by water. The purpose of this, by the way, was to distinguish it from carbon tetrachloride, which is extremely unreactive. So we had to add a few drops of silicon tetrachloride. The pupils did that. And you notice the products are silicon dioxide, which is the main ingredient of sand, and hydrogen chloride, which is a strongly acidic gas. Now, there was a problem. A problem came. And the problem was that, a bottle of silicon tetrachloride, a large bottle of silicon tetrachloride, 500 mils, had become, we couldn't open it. And the reason is it had been standing around probably for 2 or 3 years. And as the silicon tetrachloride gradually reacted with moisture through the plastic cap, because vapors do diffuse through plastic, the deposit of silicon dioxide, which is a hard white solid, had glued the top to it had become virtually welded to the glass, because glass is also made ultimately from silicon dioxide. So that we didn't know what to do. We couldn't open it, and silicon tetrachloride, if you open a bottle, it fumes everywhere. It's unbelievably unpleasant. So we had a huge dilemma of how to get rid of this. You can't put it in the waste bin, because once they crush it, the whole thing there'll be fumes, horrendous stuff. And so I decided we must try and therefore put this to good use to teaching. So I said, you can't throw it away. So therefore, what we must do is to destroy this bottle, but in such a way that we can make use of it as a chemical experiment for the sixth formers. And so what I decided to do was we would have to destroy the bottle, but by basically shooting it with an air gun. So I invented the idea of suspending the bottle on a piece of wire from a retort stand. But you see, to suspend it in water would have been a terrible waste of a chemical, you see, because in water, all it would do would just produce silicon dioxide and masses of hydrochloric acid fumes, so HCl fumes. So I thought, why don't we at the same time neutralize it, and neutralize it with ammonia? And that's what we did. So we had a calculation. We had 500 cc's of silicon tetrachloride. We did all the mole calculations. It turned out it needed about 1.5 liters of 880 ammonia. We set up the experiment on one of the school fields, and then you saw the results. So when the bottle burst, there it was. You see a large cloud of silicon dioxide and ammonium chloride. And on the next, we then went closer to inspect it, you see, wearing suitable safety gear. Now, I would like to show you a very similar version to this. It's nowhere near as spectacular, but it certainly does make a little point. And I'm just going to simply show you the reaction between strong ammonia solution and hydrochloric acid, which will give you an idea of the sort of violence of this reaction. Now, in this flask here, I've got approximately 100 centimeters cubed of hydrochloric acid concentrated. Now, here I've got roughly the same volume, slightly less, of concentrated ammonia solution. Now, this has a very, very powerful aroma. We have to always open it at arm's length. But if you notice, when I bring these two together, then you'll notice a white smoke developing. It's a most interesting reaction. It's NH3 plus HCl makes NH4Cl. Two gases react to make a solid. Covalent compounds making an ionic. Now, this is wonderful. like that, you see. But, you see, if I pour one into the other, then the reaction becomes quite violent. So that's what I'm going to do now. I'm just going to show you the reaction here, but we must make use of education, not only to show the reaction, the formation of a solid from this, in this case it will be actually concentrated solution, but it's an acid-base reaction, you see, it's a neutralization. So if you put some universal indicator, hopefully you'll get a bright red color, et voila. And now I can continue, I can now do this experiment very carefully, and what you should be watching for is it's a strongly exothermic reaction. The whole lot will boil as well. So as I add carefully, watch carefully. You watch carefully. Oh, bother, not enough ammonia. The indicator. Andres, could you please get me some ammonia? You'll find we must finish this off. Ladies and gentlemen, this is quite unacceptable. I do apologize. I had done my moles calculations were completely wrong. But Andres will shortly rescue me with a bottle of ammonia and we shall finish off the reaction. Everyone knows here that the indicator must turn to green, you see. But I'm going to very shortly tell you, have we got, yes, it'll be in a white, it's a white 1 liter bottle. I just wanted to tell you though, if you think all of this stuff is fairly exciting, I have to tell you about probably what I consider to be the wackiest chemistry lesson that anyone's ever given. Andres, thank you, allow me. Thank you very much. That's most kind, Andres. That's more than enough. Andres is such a love. There's enough there to neutralize 2 more liters of hydrochloric acid. But let's just make sure we get the result here. We're waiting for it to go. Can you see it's now nearly green? Now, I'm not going to touch that flask because it's boiling hot. Actually, I will because I'm stupid. So there we are. There it is. And it's gone green. There we are, you see. So we've now neutralized it, so that means it won't do anymore. Let me tell you about probably the wackiest chemistry lesson of all time. And this happened again in the early 80s when I had a group of pupils from Holland. We used to regularly have pupils from Dutch exchange, French exchange, German exchange, and so forth. And when these pupils arrived, I thought it would be very appropriate. I thought it's very sad that people come from another country and they all speak English, but none of us speak any Dutch or German or French or whatever. So I thought as a chemistry teacher, I thought it would be appropriate for me to actually introduce them in Dutch. So when they came to the class, you see, about 12 of these students, this is what I said to them. Welkom naar Highgate School. Ik ben erg blij jullie allemaal hier te zien en ik hoop dat jullie zullen genieten van je verblijf in Engeland. Tijdens de les van vandaag gaan wij sommige reacties van de halogens bestuderen. Ik hoop dat jullie iets nieuws zullen leren en dat jullie de vergiftige gassen en ontploffingen leuk vinden. Now, I'm sure that you picked up the most important word in there, and it was the word for explosion. I said to them, I hope you enjoy the poisonous gases and the explosions. And the word, of course, is ontploffing, in case you didn't know. Now, what happened, I then wanted to tell you, is very shortly after that, a friend of mine, I was filmed doing this chemistry lesson, you see, and what happened in this chemistry lesson, I ended it with a ginormous explosion. Now, before we show you it, I wanted to tell you what actually happened. Everyone knows, or it's part of the syllabus, is to know that hydrogen reacts with chlorine in a photochemical reaction to produce hydrogen chloride. And it's set off by ultraviolet light. And now, conventionally, you used to do this in little boiling tubes or a little test tube with lots of tape wrapped around it and a bug, and you shine a torch and it goes bang. But I did it on a much bigger scale, you see, and I have recorded, there'll be a 45-second excerpt of me demonstrating this in 1982 with appropriate safety precautions. So just to remind you, there's going to be a magnesium flare, which I produced a huge pile of magnesium powder, and a bottle, a plastic bottle, which is filled with a mixture of 50%, it's a 1 liter bottle filled with a mixture of 50% hydrogen and chlorine. So please can we now see this little clip here.
One word of advice: on no account should you ever attempt experiments of this nature unaccompanied by qualified adults or in a laboratory by yourselves. These experiments can be extremely dangerous if they are done in the absence of qualified supervision. The fuse powder is now beginning to warm up, and we shall shortly observe an extremely bright flash, and it will be immediately followed by a very loud bang indeed.
So there it is, you see, it was a successful, and I very much hope that our Dutch pupils enjoyed this class. Now, of course, I was by now beginning to give talks on a slightly larger scale to larger numbers of people, but this actually didn't prevent me from giving one-to-one lessons. I was always ready to show someone who was interested on a one-to-one basis, children, adults, anyone. So here you see, and this you see is an experiment on Hampstead Heath at midnight, a magnesium flash powder. So all of these experiments and all of these chemistry teaching continue to attract the interest of newspapers. And there you see an article, and there you see another zinc sulfide fusion, etc., the explosive side of teaching and so forth. But, dear ladies and gentlemen, in 1986, there was a calamity. In 1986, there was a calamity. And that is because with the change of the O-level syllabus, the destruction of the O-level syllabus nationwide, and with the introduction of new health and safety regulations, people became terrified of even mentioning the word explosion, let alone doing an explosive experiment. So the new headmaster who had arrived promptly and quite correctly banned all expo demonstrations. He said, we're not going to have anything to do with explosions. Now, this was, of course, a terrible, terrible tragedy for myself, but also for the large numbers of pupils. However, help was at hand. Help was at hand with the great inventiveness of young people. Now, here's one of my pupils, Ian, and Ian was obsessed with magic, and he wanted to join the magic circle. He used to run a magic society at the school, and together we got together, and there's a photo which I took of him, and we got together and we said, look, we must try and do something about this. Could we do, can we? And he said, look, sir, why don't you just simply call it Magic Society? So I thought, what a brilliant idea. What a brilliant idea. So I now the book, by the way, on the right-hand side had been given to me by another pupil some years earlier. And the idea of chemistry and magic, as you see, does work reasonably well. And one can think that things are magic, but they're actually chemistry. And therefore, we decided that we would try and reinvent the explos as magic shows. However, I had to think quite long as to how to actually get the link over. And I had the link. I had the link with sulfur. You see, sulfur was sold as flowers of sulfur. We used to buy sulfur, and so I thought, brilliant, why don't I do a magic show called Flower Power? And you see, as you know, magic is the art of misdirection. So I organized a lecture, a lunchtime lecture in Dinehouse Auditorium, and it was, to my amazement, Flower Power Magic drew a full audience of 240 people. We'd never seen so many boys crammed in for a lunchtime lecture. And I did some experiments, you see, inside the auditorium, which were quite wacky, but the most spectacular ones I did were outside in a disused swimming pool. Now, the rationale was as follows. You see, flowers of sulfur, I told the audience, the magic show was called Flower Power. And flowers, I said, have strong vital forces, we don't see them, etc. And the reason why flowers of sulfur are so called is because actually, if you look at them under a microscope, these are, by the way, flowers of sulfur, they look just like flowers. And that, you see, is a huge magnification of flowers of sulfur. And I'm sure you do agree they do look very much like dandelions. And at any rate, I told them about this. I then told them that flowers of sulfur can easily release huge amounts of energy when they combine with certain metals. So I then set up an experiment to finish off the magic show, and it was an experiment in which I mixed 3 kilograms of zinc powder with 500 grams of sulfur, and I set it off in the disused swimming pool. So this is a daytime photo of what everyone saw. Now, that was the beginning. This is just one photograph, and that shows the beginning of an enormous fireball. Notice that the sky, which was white, was completely, it looks like a nighttime photo. It's not, because the automatic sensors on the camera had to focus to get the good picture of the zinc sulfide going off. So at any rate, you see all the pupils there. You could even see the diving boards, and people were standing on top of those to get a better vision. And that's me making a hasty escape. And what was interesting is after this experiment, there was a light dusting of zinc oxide on all the cars in Southwood Lane. People were wondering where this had come from. They thought it had come from the Saharan desert, but no, it had come from another Highgate School Expo magic show. Now, at this stage, I've told you a few bits and pieces about life at Highgate School. I just wanted to show you a few more experiments on the theme of explosions. Now, you cannot talk about explosions without mentioning gunpowder. As everyone knows, gunpowder is a mixture of charcoal, saltpeter, potassium nitrate, and sulfur, invented by the Chinese about 1,000 years ago. And we can make firecrackers, we can make all sorts of wonderful pyrotechnic effects. So what I've got here is two homemade firecrackers. I made these myself. I said not homemade, but I've made them myself. They're made from simply two pieces of A4 paper, which have been rolled up together, bound with, obviously, with a strong sealing tape, and they have got a fuse in them. And we're going to, together with Andres, we're going to show you these now, how they combust. Now, in order to conduct this experiment safely, we have to obviously wear some sort of equipment, and we have to do it inside these cages. Now, the mechanism, I'll tell you what's going to happen. What happens is we light the fuse up there, you see, and once the fuse is alight, we put the cage, the cover on it like that, and then if the experiment is successful, then after 20 seconds or so, you will hear a bang. Now, there are holes at the end. There are holes at the end, and there is a small amount of gunpowder, black powder in there. And if you are afraid of bangs, then here are my thank you very much, my ear defenders. If you are afraid of bangs, then you should definitely put your hands over your ears. So I'm going to now hold. Now, Andres, are you ready? Hang around. No, okay. Let's get the light flames alight. Have you got your cover, by the way? Okay. We're going to. And everything is clear. That doesn't always work, but we can only try our best. It's important that we also stand in a staggered manner so that now you've got your cover ready to put on. Okay, so 3, 2, 1, ignition. So there we are, you see, homemade, gunpowder. Sorry, I hardly heard anything, but I presume you heard something. So gunpowder, of course, was a low explosive because it was a physical mixture. However, in the middle of the 19th century, German organic chemists specifically were able to understand the chemistry of substances, of substance which is found in living things and in plants and in animals. And what they did is they recognized that wood and cotton wool, which had been known since ancient civilizations in India and the Mayan culture, are exactly the same substance. And they started experimenting with these substances, and they were able to combine, they achieved the remarkable effect of combining cotton wool with oxygen to make it burn better. So I'm just going to show you, for comparison, first of all, how a piece of cotton wool burns. One of the, as we all agree, one of the most beloved substances known in the human race. And we're going to just light this, and I say it's a very boring experiment. I'm just going to hold hold it here, and I'll put my mat under there. So this is cotton wool burning in air. And it's a relatively boring experiment because air only contains 1/5 oxygen, and therefore it burns like this. A process which is really quite slow, and certainly no one would have used cotton wool as a fuel for heating or for cooking or whatever. And the reason is it was far more precious for making clothes. And it was in, as I said, in ancient India and in the Mayan culture that people were first able to undertake the process of weaving and make beautiful fabrics. So that was cotton. Now, the remarkable discovery which was made, as I said, in the middle of the 19th century, was to combine it with cotton with oxygen. And I've got here just a strip of cotton. It's nothing special. And I'm going to show, this has been combined with oxygen. This will burn much better. And I just wanted to show you how this burns. And then I will explain what a little more about how we could use it. So this is now cotton wool, which has been chemically combined with oxygen. It looks exactly the same as the other one, but it weighs a bit more. Before you combine it with oxygen, it weighs 1.7 grams. After combination, it weighs 2.4 grams. So this is how it burns. And as you see, quite a bit more dramatic. There is nothing left over. And this, in fact, was first produced by Professor Christian Schönbein, who was professor of chemistry at the University of Basel. He had invented the world's first high explosive. This is, in fact, an example of a substance which burns remarkably rapidly because the oxygen is actually part of the molecule which burns. It's actually, technically, it's called nitrocellulose, and technically it's quite a bit more complicated than just adding or mixing oxygen, but it's on the A-level syllabus. Those of you who do chemistry will do nitration reactions of methylbenzene. It's the same process. TNT is trinitrotoluene. Another example. Thank you very much, Andreas. We'll shortly use that. Now, I want to just very quickly, since we're on the subject of these things, is to show you a pyrotechnic device. Now, I have to tell you that many of the experiments I'm showing you have been suggested to me by colleagues. This one here was suggested by a colleague. Others have also been, and I've been very much inspired by the environment of people that I work with. Now, this here is a mortar. It's a standard, it's a professional firework, and in this mortar, we have here a fuse is put in there, and normally we fire balls of gunpowder. But I've got some ping pong balls, and all I want to do is a very simple experiment in which I will use a small ping pong ball, a small piece of my gun cotton here, and project the ping pong balls, hopefully high up into this building. They're only ping pong balls, obviously, so they can't do any damage. And I will just stand it. It doesn't need this stand there. I'll just fold a small piece there, and we have a tiny piece of fuse, and we'll just see whether they take off. That's all we're looking for. So we have to drop this carefully into the bottom here, carefully into the bottom, push in the 5 ping pong balls, then we put in a tiny piece of a fuse, which I have here, and we'll set fire to this. Now, I just have to tell you, let's hope it works. The first thing, once it's worked, then I'll be able to say something else. So, hopefully, there will be a successful propulsion with the gun cotton acting as the propellant. So, here we go, lighting a fuse there. And fingers crossed, you'll see some ping pong balls shooting out of the air. And there they are. They went somewhere high up. So that you see. Now, that's nothing. Now, one of my colleagues, by the way, this is an experiment I'm not going to do, but I wanted to tell you a story. And one of my colleagues said to me, Szydlo, why don't you do something much more powerful? And why don't you build a larger one and start firing tennis balls? So I said, this is brilliant. So I took this along with me. I tried it in a school laboratory where we have quite high ceilings. And this ball, when it hit the roof, it went up and down about 5 times. I thought, brilliant. So I tried this out at the Squires, laboratory at Cambridge University, Myers Squibb laboratory at Cambridge University, and during a lecture. And what happened when I shot this through, it went straight through the ceiling and never came down. And that was highly embarrassing because they found there was a false ceiling. So that's why I'm not going to do this. Now we're coming on now to the final experiment now, and it concerns, obviously, you cannot also, having talked about explosions and told you about gunpowder, you cannot possibly do experiments without exploding burning a mixture of hydrogen and oxygen. So what we're going to do now, we have here set up for you a special, this is a piece of standard PVC gutter, and this will be our last experiment. But before we do it, I just wanted to show you a boring experiment, and that's how pure hydrogen burns. So this is pure hydrogen, the lightest element in the universe. It's not used for children's fireworks because it's flammable, and I will just very quickly set fire to it just to show you that it burns with a deflagration. I'll just do it a bit further out. We wouldn't want a spark to fly down there. So here we are. This is pure hydrogen burning in air. There it is. But now for the finale, the very final experiment. These two balloons are filled with a mixture of hydrogen and oxygen. And they are, in Italian, we call it aria tonante, which means thunder air, as you all know. So these will make a very, very loud bang indeed. And there is a trail of gum cotton, which we've set up there, which Andres has set up there. Potassium permanganate, glycerol, and off we go. Where's the permanganate, dear Andres? Somewhere, where did we? Ah, there it is. Got it. Okay, let's go. Let's go quickly. Here we go. Right, let's go. Have we got some water to tip on it? Some water. Catalyst. There we go. Right, here we go. And now, could we have the lights off for this? It'll be far more fun. And therefore, we've put some of this. Let me just get the glycerol out. Pour it on there. There we go. There it is. Thank you very much for turning the lights off. Now, okay. A few drops there, Now stand back. Hopefully you'll see a yellow flash shooting down, and then two very loud bangs, hopefully simultaneously. Fingers crossed. And let's see, let's wait for it to start smoking. Thank you very much. So there it is. Thank you very much indeed, Andres. A million thanks. There it is. I bow humbly. Thank you very much indeed, Andres. Thank you. Thank you very much. We have now completed. We're still here in one piece. Thank you very much for your kind applause.